The objective of this topic is to give you practice in adjusting power source settings, striking and controlling the arc, manipulating the electrode, and reading the puddle in order to make sound welds.
Always think safety first when you approach any welding job. Shielded metal arc welding involves intense heat and arc radiation, so make sure you protect your eyes and skin. Always wear a non-flammable welding jacket, safety glasses, welding cap, heavy-duty welding gloves, and a helmet with the proper lens shade. The American Welding Society provides a list of recommended shade numbers for specific amperage ranges.
Before starting any job, clear slag and dirt from the welding table. Arrange your wire brush, chipping hammer, and pliers in a handy but out-of-the-way place. Gather the base metal and electrodes required for the job. Check that the power source is set up for the correct polarity, and make sure that leads are in good condition.
For this exercise, we'll be using a direct current power source with the electrode cable connected to the negative terminal, referred to as DCEN or straight polarity. Clamp the work lead to the table where it won't be in the way. Turn the power source on and adjust the current to the appropriate setting for the job. Secure the electrode firmly in the electrode holder and adjust the electrode so you can weld in a comfortable position. And always power down when you finish welding. Remove electrode stubs from the holder and hang up the leads. And clean up the work area.
Your first task is to strike an arc and produce buttons on a plate in the flat position. In addition to your protective clothing and tools, you'll need several 2x6 by 3/16 inch mild steel plates and 1/8 inch E6012 electrodes.
Set up the constant current power source for electrode negative or straight polarity and set the amps to between 105 and 110. Clamp the electrode in the holder and strike an arc.
There are two ways to strike the arc: scratching and tapping. Scratching an arc is like striking a match. Hold the electrode at an angle, scratch the end across the surface, and pull back to establish the arc. Scratching has a tendency to mar the work surface, so tapping is the best approach if appearance is important.
Tap an arc in a bouncing motion and pull back. Striking the arc is tricky. If you pull back too fast, the arc goes out. If you hesitate too long, the electrode will stick to the plate. Just give it a quick twist of the wrist to break it loose.
When you first strike an arc, pull back about 2 electrode diameters. This helps to stabilize the arc. It also preheats the base metal and starts the puddle. As the puddle starts to form, reduce the arc length to about 1 electrode diameter.
Move slowly in a circle to form a button. The puddle is really a liquid form of the weld bead, so concentrate on what's happening in the puddle and keep the electrode on the leading edge. Then break the arc with a quick twist of the wrist. Remove the slag with your chipping hammer and ask your instructor to critique your welds.
In this next exercise, you'll learn to strike and control the arc while running a weld bead. A good weld bead is even, uniformly rippled, and about 2 to 2.5 electrode diameters wide with little spatter.
You can tell a good weld by the sound. When your amperage, arc length, and travel speed are in sync, you'll hear a crisp, crackling sound, like bacon frying. Too long an arc length produces an unstable arc with a coarse, uneven crackling sound, and the arc often goes out. Too short an arc length produces a soft buzzing sound, and the electrode often sticks.
Position the electrode with a 90-degree work angle and a 5 to 10-degree drag travel angle. Strike an arc and preheat the base metal by holding an arc length of about 2 electrode diameters. Shorten the arc length to about 1 electrode diameter as you move to the edge of the plate.
Read the puddle and adjust your travel speed and arc length to keep the weld bead the same size. Sometimes you may have to slow down. Sometimes speed up. Sometimes maintain a short arc. At other times, keep it longer, all based on what the puddle is doing. Run the weld about 3 inches and break the arc.
Allow the bead to cool and chip the slag. Restrike the arc about 1/2 inch ahead of the crater using a long arc for preheat. Move to the crater and shorten the arc length to about 1 electrode diameter. Fill the crater and resume travel. Listen for the crisp frying sound.
Once again in slow motion, strike the arc in front of the crater using a long arc for preheat. As you move to the crater, shorten the arc to about 1 electrode diameter. Fill the crater and resume travel.
In shielded metal arc or stick welding, the electrode melts and is transferred across the arc to become part of the weld puddle. So, in addition to moving in the direction of travel, you also have to feed the electrode to keep the arc length consistent. Otherwise, the arc gets longer and longer and eventually extinguishes.
The finished weld should be smooth with an even ripple pattern. Check with your instructor and continue practice.